Welcome to part 2 of Introduction to Predictive Modeling. So in this section, we'll discuss the distinction between supervised and unsupervised data mining models. And then we'll introduce you some common data mining tasks. All right, so let me begin with the distinction between supervised and unsupervised data mining methods. The best way to understand difference between the two is by looking at the examples. So if you have a question like this, do our customers naturally fall into different groups? Can this type of problem best addressed by supervised models or unsupervised? This particular one, can we use classification model? Can we use a regression model? Probably not, because there is no predetermined or specific target. There is no such a thing. We just want the data tell us how they naturally fall into groups. So this is a perfect example of unsupervised data mining methods. So for instance, you can use k-means clustering or segmentation in this regard. How about this one? Can we find groups of customers who have particularly high likelihoods of canceling the service soon after contracts expire? Is it an example of supervised or unsupervised? Do we have any specific target outcome of interest? Yes. What is it? It is whether or not a customer cancels the service. If so, yes, we can encode it as yes, 1. Otherwise, no, 0. That's the target outcome, which is, in this case, binary. So this is an example of supervised data mining method. And between classification models or regression models, which one is more appropriate? In order to answer that question, you have to think about the nature of the target. The target here is yes or no. So a classification method is much more appropriate to this type of problem or question. So we have a specific purpose, there's a target, and much more useful results as a result can follow. And a host of options you can choose from, right? In order to carry out this type of classification, modeling. And there are, many different ways you can address this problem. And importantly, this type of problem requires data on the target. So not only target is well defined, but also data on the target should be available. So we need individual level label information. So to recap, supervised versus unsupervised. Supervised, there is a predetermined and clear target outcome, and then data should be available as well. And unsupervised, you don't need a target outcome. You just let the data speak by itself. You're interested in some, how data sort of naturally fall into different groups and segments. Okay, so, and then we'll look at common data mining tasks. So I'm gonna walk it through 9 of them. So we start up with the classification problem. What classification methods? We have already touched upon this. So is this a supervised or unsupervised data mining method? This is classic example of supervised, because there is a target. And the nature of target is binary, categorical, or numeric. The target is categorical. In many cases, binary. So that's when you can apply classification methods. So that's one of the most common data mining tasks, and by which you can answer questions like this. How likely is my customer to respond to our campaign offer? So what you observe is whether or not customer responded. Right? Binary response is a classification problem. Second one, regression. How much will my customer, how much service will my customer use? What's the consumption level? Is there a target? Yes, the amount of consumption. Is that categorical or numeric? Is there an order? Yes, high consumption versus low consumption. So this is a classic example of regression. Third one, similarity matching. Can we find customers similar to my best customers? Is there a target? Yes, because we do know, we can certainly define what constitutes, what comprises best customers. We can certainly characterize them. So if a customer similar to my best customer, then we can define it as yes, what best customers. If not, otherwise, then no, they are not best customers. We can consider that as the target, and accordingly we can perform supervised data mining models. Fourth, clustering. Do my customers naturally form groups? This is a perfect example of unsupervised data mining task. There's no clear target. You don't need data on target at all, right? So that's a classic example of unsupervised data mining methods. Co-occurrence grouping, also known as market basket analysis. Customers who bought a 6-pack of beer also buy a box of diapers. So that kind of co-occurrence patterns, certainly something of interest to marketers. So finding out such surprising, counterintuitive, otherwise unknown co-occurrence patterns, if that is the purpose of your the analytics, then co-occurrence grouping is the method you need. Profiling, right? So profiling is more of characterizing your profiling helps you describe the normal patterns existing in the data. So once you characterize and describe the normalcy, on that basis, you can detect or predict abnormalcy. So that's the reason why one can apply profiling approach to fraud detection. So that's a profiling. And then here's the one interesting example of profiling. So here, some researchers, they argue they can predict whether or not an online applicant, when applying for insurance services, for example, telling a truth or not, on the basis of his or her mouse trajectories. So if you think about this problem, approach this from profiling perspective, we should first build normal, typical patterns of mouse trajectories. When people fill in questionnaires on the website, and whenever a particular pattern deviates a lot from normal trajectories, then we raise a red flag and we interpret that as abnormalcy. Something is not right. So in this particular case, a person is not revealing truthful information. Next, data reduction, which is useful when you deal with a data set with many columns or many features. So say, on my data set, there are millions of columns. There are too many. They're difficult to manage. Some of them are very noisy. So by performing data reduction, you reduce number of columns, number of features to only a handful of them. But still, they capture the essence of your original features, original set of features. And in some context, data reduction approach is actually very, very, very useful. And data reduction approach is often used to extract more meaningful underlying dimensions from your observed features. And performing data reduction sometimes, not always, but sometimes, help improve the predictive power, the performance of your models. Next up, link prediction. So it predicts the presence as opposed to absence of a link or an edge in a network. So think about friend recommendation on social media platform such as Facebook. So if John and Jane share many mutual friends, but they are still not friends each other, then the platform may ask you to be friended with, if you are John, then the platform may introduce Jane to you and vice versa. So that's link prediction. Why it's called link prediction? Because the model is predicting the probability a link should exist in a given pair of nodes. In this case, a pair of people, John and Jane. So there's a specific name for this type of prediction task, predicting the presence of an edge or a link in a network. Lastly, causal modeling. This is lastly, causal modeling answers the question such as, why are my customers leaving? It's more like, the reason, the root causes. So that's the last sort of example of common data mining tasks. To sum them up, we can classify some of the common data mining tasks as supervised methods, and others are unsupervised. As you can see, there is a gray area. Certain methods can be considered as both supervised and unsupervised. But certain methods are clearly either supervised or unsupervised. Thank you.